Alright, this is a continuation on my U substitution lesson. In the previous video we started with two very basic integrals and applied U sub for them. And in this video I want to show you a slightly harder integral, which is going to be number 4. And number 3 is an example of a definite integral in which you have to apply U sub. So let's see what happens there. Let's begin with exercise number 3. Again, when you look at this is not something you can just integrate directly from what you have in your basic table. Therefore, we need to go for U sub and see if we can simplify this. So I need a U and a du, just like I taught you in the previous video. Make sure you watch that video in case you're confused. Now, what do I pick as my U? I have a couple options here. I can say U equals natural log of x. I could say U equals natural log of x squared. I could say 1 over x, right? Or I could say just the entire thing. Now the entire thing, as I said, is typically not a good option. So just forget about that. Let's forget about that one here. Imagine taking the derivative of this. It's not going to be as easy. Now, I'm actually going to go with this one because, you know, when it comes to du, this one and this one are easy to differentiate, right? This one's going to be a little bit more tedious. Now, from this one and this one, I'm going to choose this one because when I take a du, notice that the derivative of natural log of x is 1 over x dx. And when I look at this exercise, I have a 1 over x dx here. So that's going to be my du. Now I'm just going to be left off with the u squared on the bottom. So how easy that is, right? It's very easy. So that is why u equals natural log of x is my best option. This exercise is actually pretty easy. It's just designed to make it look scary, but when you notice this pattern, then this just becomes very easy, okay? So the u is going to be 1 over x dx. And again, if I rewrite this integral in the u world, I have the integral of u squared du. Look at how easy that was. Now, there's something we have to take note of. I have limits of integration, and these limits are with respect to x. So technically this should say the integral of x equals 1 to x equals 2 of blah blah blah. But typically, you know, this is obvious, so we don't really put it because we have a differential over here which is already telling you this information. But I'm writing that explicitly here just to let you know in case. So these numbers 1 and 2 are with respect to x. Now that we are integrating with respect to u, I need to put these limits in the u world as well. So that's going to be our extra step here for definite integrals. How do I do that? Very easy. So I have that u equals natural log of x. That's what I said u was going to be. So for x equals 1, which is my first limit of integration, I'm going to have that u equals the natural log of 1, right? And what's the natural log of 1? It's 0. Therefore, you know, my first limit of integration is going to be u equals 0. Again, I don't really have to write this, but for the purposes of being very explicit, I'll do it. You can do that if you want for u sub. A lot of the times I actually do it just to show that I know or something. I don't know. What about x equals 2? I'm going to have u equals a natural log of 2, which gives me a decimal number. I'm just going to leave it like that. Okay. So I could actually skip this step, okay? What's going to happen is once I integrate with respect to u, I'm going to need to go back to the x world and then substitute the values of, like, evaluate the result at x equals 1 and x equals 2. And I would get the same result. How interesting is that? But if I just move everything to the u world, I can just plug in the values, integrate, and I'll get the result. So that's even easier. I always want to go with the easiest route, so that's what I'm going to do. So this is going to be u cubed over 3. Evaluating at u equals natural log of 2 and u equals 0, I basically get the natural log of 2 cubed over 3, which is equal to 0.11 more or less. And this is my result. Let's look at this other exercise. Again, can I integrate this directly? Not exactly, not really. So that's why we need to use u substitution. Again, I have a few options. I could say u equals 1 minus 6t, which sounds reasonable. 1 minus 6t, everything to the 4th power, that sounds very hard, so I'm not going to do that. U equals 1 doesn't make any sense, and u equals the whole thing is not practical. So I'm going to pick the first option, 1 minus 6t, okay? When I do that, derivative is going to be minus 6 dt. Don't forget we're in the t world now, not the x world. So rewriting this integral, I get integral of, there's a 1 times dt, so what I'm going to do is put the minus 6 on the other side. So minus 1/6 the integral of, and I have a du on the top, 1 over u, this is u, so u to the 4th power. And this is easy to integrate, just minus 1/6. And again, using the 3 quick steps I showed you in the previous video, this is going to be minus 1 over 3u cubed, which gives me, this cancels, 1 over 18 u cubed. We have to go back to the t world, so that's 1 over 18, u is equal to 1 minus 6t, cube that, put a plus c, never forget about the plus c for indefinite integrals, and we're done. I'm going to stop here and take a break. You should take a break too and analyze what we've been talking about, and I'll show you 2 more exercises in the following video. So I'll see you there when you're ready.